Let's look at an application of statics in two dimensions, and this application is known as the two-force member. So we're actually going to develop a very general result that's related to bodies upon which there are only two forces acting. So I have a body here, and it has two forces acting on it, one in A and one in B, and I'd like to figure out what the conditions of equilibrium tell me about this set of forces. So first, let me consider moment equilibrium in A. If I consider moment equilibrium in A, what I find out is that the force in B has to line up along the line that connects A to B. So I need to have the line of action of force B line up with the line that goes through A and B. Otherwise, the force in B will provide for me a non-zero moment in A, and then I won't be able to have equilibrium of moments in A because the force in A passes through the point A. Okay, now let me now use moment equilibrium in B. Moment equilibrium in B is going to force or require the force that acts in A to also be on this same line, the line that connects the points A to B. So moment equilibrium in A and moment equilibrium in B tell me that the two forces that I'm applying onto the body have to have the same line of action. I can now, for complete equilibrium of the body, I now need equilibrium of forces in one direction. And let me go ahead and pick the x direction as I've shown here in this diagram. So I line up my x direction along the line of action of the two forces. And if I consider force equilibrium in that direction, I find out that the magnitude of the force in A has to equal the magnitude of the force in B. So I end up with this very general relationship here that when you apply only two forces to a body, they have to be equal and opposite and have the same line of action. So this is a fact that can be used to simplify a lot of analysis when you're looking at bodies that have only two forces acting on them.